Hey, welcome back to the lecture, and I'm ready with my new project here, and the project name is switching access levels. Okay, great. So I just copied the previous code. Okay, that is the function generate interrupt and our interrupt handler. Okay, and this is our main function. So what we do is I just compile the code and I'll just download the code, and let me go to the debug mode. Okay, and here you can see that initially the mode of the processor is thread mode and the access level is privileged, right? Okay, so now what we'll do is we will write some code to move the processor into unprivileged access level. Okay, so I'll just write one function called rtos init. Okay, I'll tell you why I take the example of rtos later. So it's just one function. Okay, let's say rtos init. Okay, and I implement this function here. Okay, so just observe what I'm doing. Okay, so later you can replicate at your desk. Okay, and let's say this is one function called rtos init, and okay, this rtos init, what it does is assume it does rtos related initializations. Okay, and then it calls the application task. Okay, so I'll just write call application task. Okay, so here this is actually a kernel code, let's assume that. Okay, and this kernel function, okay, does lots of initializations, then it calls application task, okay, which is user application. Okay, so let's just assume that. Okay, and I'll just implement this function over here. Okay, user application task. Okay, so let's assume that. Okay, and here what happens is, okay, rtos, the kernel code, okay, before calling the application task, okay, before calling application task, change the privilege level to unprivileged access level. What kernel does is, before calling application task, okay, that means before executing this function, change the access level to unprivileged access level. Okay, so let's do that. So if I just compile this program, it compiles. Okay, and if I just download and if I put a breakpoint here, okay, and if I execute, then okay, the control came to call application task. Okay, so before calling this function, okay, here you can see at this time the access level is privileged, right? Okay, so now let's change it to unprivileged. Okay, here what I do is I use Kimsys core APIs, okay, to access this control register. Okay, the API is actually __ set control. Okay, so here you have to mention the value. Okay, and it will change the control register contents. Okay, so if you want to know how exactly it is implemented, just select it and right click and click on go to definition. So it is implemented in Kimsys armcc.h, and here you can see that, okay, it takes a value here. Okay, and then it uses the inline assembly code in order to change the register content. Okay, so now we'll go back to our code, and the correct way to change this control register is, first let's read the value of the control register. Okay, define a variable here, value of unsigned 32. Okay, so __, first I will get the value of control register. Okay, so first let's get the value, then now the value actually came into this variable, right? So because I just read the control register here. Okay, and then what you have to do, you have to set the 0th bit to 1, isn't it, in order to make it unprivileged, isn't it? So what I do is value or is equal to 0 cross 0 1, right? I actually set the 0th bit of this value, isn't it? Okay, and after that I call underscore underscore set control and I pass this value, right? So this code actually changes the access level of the processor from privileged to unprivileged. The RTOS init function, okay, before calling the application task, it changes the access level of the processor. Okay, so now let's see how this works. Okay, now let's compile this code. Great, the code is compiled successfully, and so what I do is I'll just put a breakpoint here. Okay, so at the beginning of this function. Okay, and let me just download this code, and let me go to the debug mode and just hit run, and I'm now at the beginning of the RTOS init function, and here you can see that the mode is thread, that's fine, and the access level is privileged, that's fine. So that means the RTOS has done all its low level initializations in the privileged mode with a full control over all the restricted registers. Okay, but the RTOS init function is very smart. So what it does, before calling the application task, it actually changes the access level to the unprivileged, because the RTOS init function doesn't want to give full control to the application task. Otherwise the application task may touch all the restricted registers and it can create chaos. Okay, it can freeze the system. So now let's see what happens. Okay, so now the control is at this point. Okay, and now let's remove this breakpoint. Okay, and also observe the value of the control register. The control register is currently 4. Okay, and when I hit run, here it is, the mode is changed to unprivileged, and look at the value of control register. Now it is changed to 5. That means this last bit is set to 1. Okay, so now being in unprivileged mode, the RTOS calls the application task. So the moment you come here, everything is unprivileged access level. Okay, so now I come to the call application task and I remove this breakpoint also. Now it returns. Okay, returns to where? Returns to while 1 here, isn't it? Right, so now let's hit run, and I came back to while 1, and look at the access level, it is still unprivileged.